Okay, guys, we're continuing with check your skills, and we're looking at question 3 now. This is exercise 5.10 in your book on page 148. And we've got cos x minus y times cos x plus y on the left-hand side is equal to cos squared x minus sine squared x. What a lot of you want to do is you want to look at that identity and go, oh, we've got the minus cos sine squared. And we go look at this and we quickly sit there and go, okay, this ends up being 2, oh, sorry, not 2, cos 2a. And in this time, cos 2x. And when you write that x, you're going to sit there and go, but there's an x and there's a y. Guys, they are two different angles. This only works when you've got the same angle for each one. These are two different angles. You cannot use that identity for this one. Okay, so let's delete that. Let me just erase it. It's easier. Now we've looked at the right hand side. We've realized we can't do any of that. So we're going to go work on our left hand side. What you want to notice is that this guy is a compound angle. It's the cos A plus B, the cos X minus Y. If you end up having cos A plus B, whatever sign is here gets swapped over there. And I always say cos starts with everything, and cos is what we put on the one side because everything stays on the other side. And then we end up having the two angles be A and B. The order of the angles will always be A and B. It doesn't matter which sine or cos it is, and you saw that in question 1 and question 2. Anyway, the sign in a cos changes to the opposite, where the sign in the sine compound ratio remains the same. And in this instance, I didn't do that. Let me go erase those, otherwise you're going to get confused. The sign, let's get a drawing pen. If it's a plus in there, it will be a plus out here. And if it is given as a minus, it will be a minus. Sorry for that edit over there. Okay, so let's go back to this. We've got this compound angle, and we are going to expand it. I'm going to do it in a different color. I'm going to make it that color, and then I'll make this one this color. So left-hand side, you end up having your compound angle, cos x, the cos's all stay together, cos y. The sign is a minus, therefore it becomes a plus. Sine x, sine y. And this one is being multiplied with this one. So our left-hand side, that term gets multiplied. Let's change our color. This is the next identity. This identity is all the coses stay together when it's a cos identity, and the sign changes, and then the signs come into play. So now we've got two brackets. These brackets are exactly the same. The only difference between each bracket is the sign within that bracket. And when we have a bracket that is exactly the same and the signs are different, we end up doing dots. And dots is difference of two squares. In a dots bracket, you won't have a middle term. You won't have your nose multiplying with your mouth to give you a middle term. You'll only have your eyebrows. So the eyebrows, so cos x cos y times cos x cos y, firsts times firsts. If you're using FOIL, you're going to end up having cos squared x times cos squared y. And then you end up having lasts times lasts, which ends up giving you a minus in the middle, sine squared x times sine squared y. So at this point it does get a little bit tricky, because what do we notice? We're always working towards the right, okay? We've got cos squared x. Here's cos squared x. We've got sine squared here. Here's sine squared y. But I've got this guy in the middle that doesn't make sense. I need to get rid of him. So I need to figure out how to get rid of him. And I end up looking at this identity to be able to do that, okay? So if I keep what I originally have, I end up, I'm going to put this, keep this separate from this, okay? So we're going to put a square bracket. We keep cos squared x. And cos squared y, I can change, if I want to know what cos squared y is, if I rearrange this equation, take the sine squared across, it becomes 1 minus sine squared. So I'm going to change this identity, and let's make it a different color, into 1 minus sine squared y. Close my square bracket, put my minus, open my square bracket for this side. I want to keep the sine squared y. It's not a 2y, it's a squared y. I need to get rid of the sine squared x. That's a sine squared. How do I change it? I change it by taking this cos squared across. I make this the subject of the formula, and I get 1 minus cos squared x. So I'm going to put that in here. I'm going to keep the sine squared. Let's keep the one that we want in front, sine squared y. And I'm going to open up the bracket of this that I'm going to change into 1 minus cos squared. And what are we dealing with? An x, so cos squared x. All I did was apply my identity, the rearranged form of the identity for these two items. Now, I simplify this by distributing into these brackets. Cos squared x times 1 gives me cos squared x. Cos squared x times minus sine squared y gives me minus cos squared x times sine squared y. So I'm done with this side. Now I'm going to deal with this side. Keep the bracket there. Everybody forgets how important this bracket is. So we end up having a sine squared y times with 1 still leaves me with sine squared y. Then I take that sine squared times it with my minus cos squared x. So I'm going to write it as, I'm going to keep cos first, cos squared x times sine squared y. Close my little square bracket. What do I do with this negative? Well, I would distribute it in, and this negative times is here and makes that a negative, and times is with that guy and makes this a positive. Okay, so once I've done that, my brackets then fall away. I just don't feel like writing out this whole sentence again. So I end up having the minus, and this bracket has this minus has now been dealt with, so that minus and that plus. So we end up having like terms here. Do you see, let's get another little color going on here. Do you see that I have minus cos squared x sine squared y plus cos squared x sine squared y? And what ends up happening is a minus 1 plus a 1 or minus something, and it's adding its same self to itself. You end up cancelling those, which means you are now left with cos squared x minus, don't forget that little yellow minus, sine squared y. And therefore, your left-hand side is equal to your right-hand side. This one was a little bit of a tricky one just because of this ugly thing here. Let's see if we can do a spotlight on it. Just because of this ugly thing here and that one over there. You got to this point and you're like, okay, I know what I'm doing. I did my dots. I did everything. But now I've still got this guy and I've still got this guy. And they shouldn't be there. I'm only supposed to have this guy and that guy. Well, change these. See if changing them to these ratios, these trig identities would have worked. And scribble around. Remember, you're like Sherlock's Holmes in this instance. Sherlock Holmes has to try to figure out multiple paths to the truth, okay? The more you do this, the better at it you'll become because you start choosing the right identities that bring you down to where you need to go. A couple times you need to use your pencil and erase and go back. I don't recommend erasing just because it deletes what you've just done and it doesn't allow you to see where you made your mistakes the first time around. So keep doing those sums and don't erase them. Do them in pencil if you have to. Put a nice, pretty, neat line through it, but don't erase them. Keep them there so you can see that you actually faltered and how your brain eventually got you to the right path.